Let's now turn our attention to another key transforming operator, actually several transforming operators that are defined in the mono class. And these are very cool. If you recall before, we talked about map in the context of mono, which is very straightforward. And now we're going to talk about flatMap and flatMapMany, which are really interesting. And they're used to transform the values and or the types emitted by a mono and to do it in a really cool way. So the flatMap method transforms the item that's emitted by the mono, and it's typically intended to be used asynchronously. You can use it synchronously, but it's way cooler when you use it asynchronously. That's the beauty of monos and the beauty of Project Reactor is the asynchronous use cases. And you can see that it takes a function as a parameter, which does kind of what you typically would expect functions to do. They take a value that comes in as a parameter, and they apply some kind of transformation, and they return a result. And as we'll see here, it's going to be something that can change the value or change the type. What comes back from flatMap is the value that's emitted by the mono that's created by the function, by the transformer. And as I alluded to before, you can transform the value and or the type of elements. So it's like the caterpillar turning into a butterfly. It gets transformed if you want. So here's an interesting use case. We will look at this use case in more detail when we get into the discussion later of the case study. What we're going to do here is we're going to make a random big fraction by calling the make big fraction async method. And this is going to make the fraction asynchronously. So it's going to be running in a background thread. Let's say we're making a really big fraction, and so we want to do that in the background. We don't want to block. So then what's going to happen is we're going to say BFM1, which stands for big fraction mono 1, dot flatMap. And what that says is when the big fraction finishes being created asynchronously, then take the results, which is this BF thing, and multiply it asynchronously by some big constant, big fraction constant, big reduced fraction. And as you might expect, because this is called multiply async, that multiplication is going to take place in a background thread, just like making the big fraction in the first place took place in a background thread. And so that's going to give us back a mono to the results of the multiplication of this big fraction by this constant. Now, as you might expect, if you remember what flatMap did in the context of Java streams, and it also did it in the context of Java optionals, it denests things. You don't end up with nesting. And a way to see that here very vividly is to take a look at what would happen if we used map instead of flatMap. So if we use flatMap, we have no nesting. If we use map, we're going to have a mono to a mono of a big fraction. And that leads to a much more awkward result. So that's the problem we're going to have if we do that. So flatMap denests stuff. RxJava has a flatMap method or operator in its single class that works the same way as it does in Project Reactor, avoids nesting. Except this time it works with singles, not monos. This is also very similar to the then compose method that you've hopefully been getting a bit more accustomed to with assignment 3. There's a couple cases where you use variants of then compose, like then compose async. And again, the whole goal of that is to avoid nesting stuff. Let's now turn our attention to the flatMapMany method. And this is a really interesting method. It transforms the item emitted by this mono into a publisher, and the parameter is a function that produces a sequence of elements of type R. So it's going to basically take a mono and create a flux from it. And we'll get back a flux that will receive the emissions that come out of flatMapMany. Now, this is a little bit mysterious at first, and before we get to the use case, we'll just, again, underscore the fact that this is going to be able to transform the value or the type of the element, just like map and flatMap. That's not different. And here's a simple example. We'll look at this example in more detail later because it really is something that's hard to show on one slide. But basically what we're going to do here is we're going to get ourselves a flux from an array. So we're going to have an array converted into a flux of big fractions. And then we're going to go ahead and use a from callable factor method to get ourselves a single big fraction. So we have this big fraction flux, which is a sequence of things. We have this big fraction mono, which is one thing. And then what we're going to do is we're going to concurrently transform the mono result into a flux result. So what the heck are we doing here? This is actually really, really cool idiom to know how to use. So what we're doing here is we're saying when the big fraction mono, which we got from callable, completes, then we're going to use flatMapMany to take that big fraction that came back from the callable, and then we're going to go ahead and take the flux that came back from array when it completes. So now we're saying when the mono completes and the flux completes, when both of those things have been created, then we're going to take the BF2, which is this flux, and we're going to say for every element in the flux, go ahead and in parallel in the background, multiply the BF1, which is what came back from the callable, the single element, by each of the elements in the flux one by one. So for every element that's in the flux, we're going to go ahead and take that and we're going to multiply it by the big fraction that came back from the mono. So you can kind of think of this as a loop where you get like one element first, and then you get a second array of things, and then you say, for each element in the array of things, take each element one at a time and multiply it by the first element you got back. So a good example might be if you had a bunch of numbers, let's say you were doing some kind of currency conversion program, and you had a whole bunch of values that were in euros, and you wanted to convert all of the values in euros to yen, just for sake of argument. And you had a conversion factor, which was the multiplier, 0.75 or whatever the conversion factor is from euros to yen. I don't know what that would be, but it would be something. And so you would say, for each of the currency values we want to convert, multiply it by the currency rate converter. So that would be sort of the use case. So you've got a bunch of things that you want to apply a single value to. And we're going to get the single value asynchronously, and we're going to get the sequence of things we want to multiply asynchronously. And when both of those things are finished, then we're going to asynchronously apply each of those values to multiply it by the rate converter. That's the way to think about this. And so that's exactly what this particular piece of code is doing. Super, super powerful idiom. Great question. So the question here is, for the example I just gave, what would be the flux, what would be the mono? So the mono's result would be the currency conversion rate, like 0.75 or whatever it is. And the flux would contain all of the different values that needed to be converted. So let's give a really specific example, because I wrote a program like this last summer that was pretty cool. We wrote an airline flight listing program. And what it would do is you would say, I want to fly from, Nashville to Luxembourg, or some airport. I want to fly to Beijing, or wherever you want to fly to. And so it would go out and it would query a bunch of airline databases and get back lists of flights and their costs. So you would say, for like here to Beijing, there might be 10 airlines 10 flights that'll take you there, and each of them would have a separate cost. And what we wanted to be able to do is those costs, let's say that they were Chinese airlines, the values might be in yen or whatever the Chinese currency is these days. And what we would do is we would take each of the results, and we want to see them in dollars. And so we would figure out we would also make a request to find out the conversion rate from dollars to yen. And then for each of the various values we had, it would go ahead and would basically multiply the rate by the value from each of the airline flights that came back. So that in that case, the flux would be the sequence or the stream of values, airline flight costs in yen, and then the mono would be the multiplier that you would get to make the exchange rate work properly. So the question is, why is there this underscore, underscore, underscore? I think it's actually 3 underscores here as the first parameter in map. So just to remember, the first parameter is always the name of the particular object that's being emitted using a lambda expression, right? So up here, for example, we see that when the BFM, which is the big fraction mono, is going to complete, BF1 will be that value. Likewise, you can see here with BF flux for each element in BF flux, BF2 is the value that we're interested in. So what's happening here, this is a very cool little idiom we'll talk about more when we get into talking about fluxes. What we're doing here is we're saying for each big fraction BF2, emit that big fraction using just. So it's basically saying flux.just, emit this particular value. And that would then go through subscribe on. Subscribe on doesn't make any changes to things, it just emits it there. And so we could have designated that as map, BF3. We can't say BF2 because there's already a BF2 in scope. So we could have said BF3 or BFX or whatever we want to say instead of underscore, 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 except there's no real need to do that because we're using the binding value here. BF2 is the value that we want. So we can just ignore it. And this is just an idiomatic syntactic way of saying, I don't care what the name of this thing is. It's there syntactically, but I'm going to get the name from the enclosing scope. So it's just a trick. It's not a reserved word. It's just a naming convention that says, I don't care to name this thing because I'm not going to use it. So that, you can almost think of it like, not used or, whatever, TBD or not interesting, something like that, NA. There's a method in RxJava, which is strange enough given a different name, which is called flatMap Observable. And it works the same way that flatMapMany works. They probably could have called flatMapMany flatMap flux. And that would have been similar to flatMap Observable. But they decided that many was a more intuitive way to say that you're getting many things back from one. All right, so that's the end of that example. Again, or that operator, those operators. We'll see these things in full glory here shortly when we take a look at the case study, which is going to be really cool.